numbers. In this particular lesson, I want us to look into this topic on the board, that is source, which is a topic in mathematics. Now, before we proceed, what do we mean by source? By source, we mean the roots of rational numbers whose values cannot be expressed as exact fractions. Of course, we know we have what we call rational numbers and irrational numbers. By rational numbers, we mean those numbers that can be expressed as what ratio, as the term implies. And these numbers can be expressed as fractions with exact values. These are rational numbers. For example, if you have 2/3, 1/2, 2.5, 1.4, all these are what? Rational numbers. They can be expressed in terms of fraction, they are integers. Now, provided that their denominator is not equal to 0 anywhere. Now, by irrational numbers, as the opposite concept, opposite term, irrational numbers are those numbers whose values cannot be expressed as exact fractions, and their exact values cannot be determined. Yes, cannot be determined when expressed as such. So these are irrational numbers. Therefore, by implication, a surd or surds are what? Irrational numbers. But we get them by the roots of what? Rational numbers, whose values cannot be what? Expressed as ratio or fraction of integers. These are surds. Now let's proceed. For example, something like pi, the value pi is an irrational number. For example, we have a √2, that is √2 or √3, √5, √12, √20. All these are what? Whose the square root cannot give you a perfect what? Square. Once the square cannot give you a perfect square in expression, then it is a surd. Yeah, that is it. So let us look at roots of surds. Let us look at the roots of surds. Now, these are the roots guiding surds. We have if you have root or surd xy, it can equally be expressed or separated in this expression to be root x times root y. It is equivalent to that. So if we have root x over y, it can also be expressed in this form, and it is also correct, they're equivalent. It is equal to, or it equals root x over root what? Y. Then under root 3, that the root number 3, if you have surd or root x plus y in the common surd or root here, it is not equal. This line means, this cancellation means that it is not equal, not equivalent, can never be. It's an error to write this in terms of this, because we have this. If you do it here, it is error. So it cannot be equal to root x plus that separated root y. It is not equal to this. So this thing doesn't work. This one is correct. This one is correct. Then, similarly, if we have surd or root x minus 1 in a common s minus y in a common surd, remember this sy I'm using here symbolizes the formats. They represent numbers we could meet, or integers we could meet because of surd. So if you have surd x minus y, it is not equal to surd x minus surd y separated. So this one is not equal. Not equal. That's what you mean. This one is not equal. So that is it. This one is not equal to this. Not equal to this. Now, let's proceed. Then there are what we call similar surds. So these are basic rules. They are what we call similar surds. By similar surds, surds that are what? Are the same. So surds are said to be similar if their irrational parts are similar. But if the rational parts, of course, in a surd like this, if I have a root x, the a is the rational part, the root x is what? Irrational part of the surd. So if I have a root x and the b root x, they are similar. These two are similar because their irrational parts are similar. Because of this and this are the same. That's why, because of this and this are the same. The surds are the same. That's why it is similar. Not minding the what? The rational part, the one outside. Then look at the number 2 scenario. If I have a root x and the a root y, they are not similar. Reason: the surds are not similar. They are not the same. The irrational parts are not the same. Despite the fact that this rational part A and A are the same, but it does not qualify this to be similar. So just mind these conditions. So with these basic principles and rules of solve, we now go into example for basic understanding, because we can't exhaust solve today. We still have we shall still meet many examples on this solve in the next episode or subsequent classes we shall have here. Now, looking at the one on the board here as a form of introduction to the rules or principles, I have here simplify. We can simplify solve. This simplification of sorts. Simplify the following sorts: root 50 or sort 50, B sort 45. Your question number to say express the following sorts as single sorts. The following as single sorts. So you can be given sorts that have both rational and irrational parts, and we are asked to express it as single sort. These are single sorts. We are asked to simplify them. So they have, by simplification means you simplify a sort that you have both rational and irrational parts. Then when you are given this one, then you have to take it back to single sort. It means to get it to something like this. So let's solve it. Then for A, number 1A, we have sort 50. So how to simplify this sort into rational and irrational part is simple. You think of two numbers, two integers, that when you multiply them, their product will give you 50, such that one of the factors will be what? A perfect square, and the other one will be what? An irrational integer. So look at two numbers that when you multiply them, you will get what? 50, so that one of them will be what? A perfect square. We don't want to buy a perfect square. Perfect square means something like square root of 4 to square root of 9, 3, and so on. This one that have perfect square. So, and the other one component or part of it or factor of it will be what? Irrational sort. Now, for example, let's make a little drill for you to understand this. 50 now, we can see that 10 times 5 will give us 50. But square root of 10 is still irrational. Square root of 5 is also, that root 5 is still irrational. Square root of this one is also what? Irrational. So it does not work. So if you look at, think of 25 and 2. You can see that for 25 and 2, that 25 is a perfect square, and 2 is an irrational sort. That root 2 is irrational sort. Root 25 is a perfect square. The perfect square, that is it. So with this, you can see that this one works. So that's they have to make the analysis. So we have equals to square root of 25 times 2. And that will give us square root of 25 is what? 5. Then the one that is perfect square, now you give it out. So square root of 25 is 5, which will give us what? It's like saying square root of 25 times square root of 2, which will give you remember what we did, what we said here? You see, that was we just applied here. Square root of 25 times 2. Square root of 25 is 5. Then 5 sod 2. That is the answer. 5 sod 2 is the answer. Then for B part of the question, we have sod 45. I believe by now you must have thought of the numbers that we make of this. So sod 45. What are the two numbers? Let us do the drill. Consider the factors. You know that 3 times 15, you know that 15 times 3 will give us 45. But they do not qualify. Square root of 15 is not a perfect square. So 3 is also irrational. So it doesn't qualify. We think of two other numbers. Well, let us think of other products or factors of this that can give product to 45. What of if you think, consider 9. 9 times 5. You believe with me that 9 times 5 is 45. And what do you observe? You can see that sod 9 is a perfect square. And sod 5 is what? An irrational. So that is the secret. So this gives us sod 9 times 5, which is equal to sod 9 times sod 5. And square root of 9 is what? Perfect square. 3 sod what? 5. Answer. So that is it. So you learn to do the analysis. Then let's go to number 2. Number 2 question required us to express this in form of this single source. The first question is for us to treat this to become like this, to have rational and irrational parts. Then the second question asks us to do a work to bring it back to this format. So we have A, we have 2 sod 5. And when we ask what are we going to do now, it's very simple. What you need to do is do the reverse of the operation we did here. 2 sod 5. Simply, this one is the rational part. So square it and multiply. You know, opposed to square root is square. Opposed to square root is square. So square this now and multiply it by this one. You get the single sod. Very simple. So that will give us square root of 2 raised to the power 2 times 5. Because the square root of what we have here gives us this 2 outside here. 2 raised to the power 2, which is what? 2 raised to the power 2 is what? 2 times 2, 4. So square root of 4 times 5, which equals to what? Square root of what? 20. Simple. That is it. That is the secret. Because if you treat this one now, if you piece this down, you get back this. This will give you sod 4 times 5. And square root of 4 is what? 2 outside. And sod 5 here. Okay. Then number B, I guess we can solve this one. We have 7 sod 2. This is simply square root of 7 square, because it is the square root of something like this or 7. So opposed to square is square. So 7 square times 2, this one here, which equals square root of 7 raised to the power square. The 7 raised to the power 2, that's 7 square, means 7 times another 7, which is 49, which is what? Sod 49 times 2, which equals 49 times 2 gives us what? 98. So 98. Simple. So this is the simple. There's no magic there, just simple analysis. So with these basic examples, I believe you have understood the basic operations of the word, at least the first principle of or rule of what? Sod. Then in the subsequent classes, we are going to look into conjugate of a sod and simplify further addition of sods, subtraction of sods. So follow me in the next episode. The subsequent classes we are going to have will be updated on the online page through the YouTube and the Facebook page. Thank you for paying attention. I remain your tutor here, Joe Newton online class. Therefore, more on the solutions in mathematics and physics, you can simply reach out to me through my